Somewhere out in the solar system, orbiting the Sun every 271 days, is an asteroid called 2023 DW. Recently, it passed within just 9 million kilometers of Earth, measuring about 50 meters in diameter, roughly the same size as the rock that caused the Tunguska event. 2023 DW initially appeared to pose concerning odds of impacting Earth in 2046, estimated at 1 in 560. Fortunately, this means there's still a very good chance it will miss us entirely. But what if something altered its orbit, placing it on a direct collision course with Earth? How devastating would such an impact be if it struck a populated area rather than remote Siberia? And could we deflect or nudge this asteroid away before it hit us? Discovered in February of this year, 2023 DW is currently racing through space at about 86,400 kilometers per hour. Scientists have estimated it has around a 1 in 560 chance of striking Earth on Valentine's Day in 2046, although some researchers propose a 1 in 400 chance. There's even a projected impact zone marked in red on one image, stretching from the southern tip of India all the way to the eastern coast of the United States. To gauge risks, scientists use measures like the Torino scale. Most near-Earth objects, NEOs, rank 0 or below, indicating minimal concern. However, 2023 DW was initially assigned a Torino scale score of 1, which is slightly more worrisome. As astronomers refined their calculations, the probability dropped to 1 in 1,584. Still, questions remain. Could that risk unexpectedly rise? And what would happen if our projections are off? A NASA Center for Near-Earth Object Studies scientist compared this scenario to the Tunguska event. A 50-meter-wide asteroid exploded above a desolate part of Siberia in 1908, unleashing an airburst equivalent to a 12-megaton nuclear bomb. Had it detonated over a major city, the catastrophe would have been unimaginable. If 2023 DW were to collide with Earth in a populated region, it could release similar destructive power. The 1908 Tunguska blast leveled trees across a 2,000-square-kilometer area, incinerating millions of them. Witnesses described a fireball brighter than the sun, and pressure waves were detected globally. Now imagine that in the heart of a modern metropolis. So, what can we do if faced with an actual threat? Both NASA and the European Space Agency, ESA, have been testing asteroid deflection strategies. NASA's Double Asteroid Redirection Test, DART, recently proved that crashing a spacecraft into an asteroid can alter its orbit. Following this success, the ESA plans a mission called Hera, set to launch in October 2024. Hera will explore the binary asteroid system Didymos, specifically its moonlet Dimorphos, which DART already impacted, to analyze the crater and measure the moonlet's mass and composition. This data could help us refine planetary defense methods for future threats. By the time 2023 DW makes its closest approach in 2046, we should have a clearer understanding of how to respond to an asteroid impact scenario, thanks to DART, Hera, and other advancing technologies. Still, mitigation plans typically aren't fast-tracked unless odds of impact rise above 1 in 100. If we do encounter an especially stubborn asteroid, there's another wrinkle. Some space rocks might be far more resilient than anticipated. Research on the rubble pile asteroid Itokawa suggests certain asteroids formed billions of years ago and have survived violent collisions nearly their entire existence. Their porous nature lowers the efficiency of kinetic impact strategies like darts. In such cases, scientists might have to consider more aggressive measures, such as nuclear blast deflection. Increasingly, we're discovering new asteroids with surprising traits that could complicate our defense strategies Missions like Hayabusa, OSIRIS-REx, and Vera Rubin Observatory's upcoming survey, starting in 2024, will help identify thousands more asteroids that might pose a hazard. NASA's NEO Surveyor mission, scheduled for 2028, will further boost our asteroid detection capabilities. Innovative, cloud-based data analysis methods are also under development, allowing scientists to determine more accurately which threats are genuine. As technology advances and we explore the solar system, the odds of finding more dangerous space rocks rise, but so does our capacity to defend against them. Indeed, there are millions of asteroids drifting in our solar system. Several thousand meteorites, many weighing a pound or more, hit Earth every year, usually landing unnoticed in remote forests or oceans. In 2004, scientists discovered a massive 20-million-ton asteroid that, at first, appeared to have a 2.7% chance of hitting us in 2029. An impact from a rock that large would be devastating, but what are the real odds? And how can we prevent such a big asteroid from hitting us in the future? Apophis, discovered on June 19, 2004, by astronomers in Tucson, Arizona, measures about 2,100 feet across, roughly the length of 3.5 football fields. Early predictions suggested a significant chance of collision on April 13, 2029. Since then, optical and radar telescopes have been tracking Apophis, and scientists are now fairly confident in its path. Current calculations show it will come extremely close, about 19,800 miles from Earth's surface, which is well within the orbit of the Moon, over 238,000 miles away. In fact, the asteroid's trajectory might even bring it closer than some satellites. But what if a gravitational tug or another factor changes Apophis's path, and it does collide with Earth? It's well known that an asteroid impact could cause mass extinction if the asteroid is large enough. The late physicist Stephen Hawking even declared asteroid collisions the biggest existential threat to all life on Earth. If Apophis were to smash into the planet, the impact would unleash more than 1 billion tons of TNT. By comparison, the massive Beirut explosion in 2020 involved just 1 kiloton of TNT, striking directly over a major city. Apophis collision would not only kill millions, but drastically alter Earth's ecosystem for centuries, though perhaps not cause a full extinction-level event. Asteroids have played key roles in shaping the solar system, including mass extinctions here on Earth, the formation of our moon, and more. On Mars, an ancient asteroid collision might have created its 2 differently shaped hemispheres. Uranus, meanwhile, was tipped on its side by a planet-sized collision. While a rock like Apophis rarely passes this close to Earth, smaller asteroids, between 16 and 33 feet in diameter, come within comparable distances far more often. Such objects are classified as near-Earth objects, NEOs, and astronomers worldwide track their orbits. NASA's Earth Impact Monitoring System automatically flags potential threats within the next 100 years. Interest in NEOs spiked in 1994, when fragments of Comet Shoemaker-Levy 9 plowed into Jupiter, an event captured live by telescopes on Earth. As of January 2019, scientists have identified nearly 20,000 NEOs. Most are asteroids, while around 100 are comets. These NEOs fall into categories based on their orbits, including Amor, Apollo, Aten, and Hera classes. Apollo asteroids are Earth-crossing objects with orbits larger than ours. Aten asteroids also cross Earth's orbit but have smaller paths around the Sun. Apophis is an Aten-class asteroid. After its 2029 close approach, its orbit will stretch wider than Earth's, thus reclassifying it into the Apollo group. Scientists rely on scales like the Torino scale to rank the probability of an asteroid's impact. Apophis is currently estimated to have almost no chance of hitting Earth in 2029. Yet space is unpredictable, and one must account for uncertainties like gravitational keyholes, small zones in space where a passing asteroid's orbit might shift to create a future impact. The odds for Apophis colliding with Earth in 2036 remain extremely low, about 1 in 100,000, earning it a Torino scale of 1. In 2013, NASA launched the Dark Energy Survey, DES, to map part of the southern sky. By 2019, it had collected vast data, including a mysterious blurry dot, later identified as a new comet, officially named C-2014 UN-271, or Bernardinelli-Bernstein, after its discoverers. This comet, hundreds or thousands of times larger than a typical one, could measure anywhere from 60 to 125 miles across. For comparison, the asteroid that likely wiped out the dinosaurs was only 6 to 9 miles wide. Bernardinelli-Bernstein is still so distant that its exact size is uncertain. Its orbit around the Sun takes about 3 million years. Astronomers believe it originated in the Oort cloud, a distant region filled with icy debris from the solar system's birth. It should reach its closest point to Earth in 2031, but will remain about 11 astronomical units away, beyond the orbit of Saturn, posing no known threat. Meanwhile, a more concerning object is the near-Earth binary asteroid Didymos, accompanied by its moonlet Dimorphos. It's large enough to create a 6-mile-wide crater and devastate any city. NASA's DART mission aims to slam a half-ton spacecraft into Dimorphos at about 4 miles per second. This kinetic impact test, scheduled for collision in late 2022, could show us whether we can meaningfully alter an asteroid's speed or direction. If successful, it would be a first for planetary defense. Still, NASA simulations indicate our capacity to intercept a hazardous asteroid depends heavily on early detection. In a recent exercise, scientists concluded that even 6 months' warning is insufficient to launch a deflection mission. The only viable solution in that hypothetical was an evacuation of the impact area. Building better surveys and telescopes remains paramount. NASA's NEO Surveyor mission, to launch in 2028, will scan large swaths of sky, and the Vera Rubin Observatory, opening in 2024, will likewise catalog thousands of new asteroids. Additionally, some amateurs with homemade telescopes have detected important objects like 2I Borisov, an interstellar comet abundant in carbon monoxide. Comprehensive data gathering on such objects helps astronomers deduce their origin, composition, and potential threat. Looking ahead, we face a universe teeming with millions of asteroids of varying sizes. Although thousands of meteorites strike Earth annually, most land unnoticed in remote areas or oceans. Occasionally, we see something more dramatic, like the 2013 Chelyabinsk meteor that exploded over Russia, injuring over 1,500 people and damaging thousands of buildings. Scientists must carefully track orbits to determine if and when an object might collide with Earth. NASA's risk chart includes countless potentially hazardous asteroids, PHAs, that pass within 0.05 astronomical units of our planet. If we do spot a major asteroid on a collision course, can we stop it? It depends on its size and how far in advance we detect it. If an impact is just a year away, our options are mainly limited to evacuations. However, if we have 7 to 10 years, we can consider methods like nuclear detonation or a kinetic impactor to alter the rock's path. Concepts like the gravity tractor, laser ablation, or solar energy focusing are still in various stages of theoretical and practical testing. NASA's forthcoming DART experiment and ESA's Hera follow-up represent a significant leap in real-world testing of these ideas. Close calls like Apophis and Didymos provide a valuable chance to refine our planetary defense measures. The 2029 flyby of Apophis, passing just 19,800 to 800 miles from Earth, will be an unprecedented opportunity to study a sizable asteroid up close. Radar imaging can capture surface details just feet across. Meanwhile, Comet C 2014 UN-271's approach by 2031 offers insights into distant objects from the Oort cloud. Although these specific visitors likely pose no harm, their presence underscores the need for ongoing vigilance. Asteroids like Shoemaker-Levy 9, which collided with Jupiter in 1994, remind us that large impacts do occur, and not just on distant worlds. The gas giant Jupiter seems to play a cosmic Big Brother role by slingshotting or absorbing many would-be threats. Its enormous gravity field yanks comets and asteroids off course, sparing Earth from frequent catastrophic impacts. One such example was Shoemaker-Levy 9, whose fragments pummeled Jupiter's atmosphere with an energy equivalent to 300 million atomic bombs. Observers on Earth watched colossal dark scars appear and vanish within Jupiter's thick, swirling clouds, an awe-inspiring event that led to more robust planetary defense research. In the grand scheme, asteroids have shaped the evolution of our solar system, molding the surfaces of worlds and even possibly providing Earth with water or contributing to mass extinctions. Though the distance to our solar system's asteroid belt between Mars and Jupiter is vast, and collisions with Earth remain rare, scanning for NEOs is crucial. Our detection methods rely on comparing multiple images of the night sky, then calculating each object's orbit. For an object over 450 feet across, any Earth-crossing path warrants special concern. In summary, while there's no immediate threat from 2023 DW Apophis or Bernardinelli-Bernstein, the ongoing discoveries of near-Earth objects remind us that vigilance is critical. With improving telescopes, data analysis techniques, and missions like DART and Hera, we're steadily enhancing our planetary defense strategies. Ideally, if we spot a genuinely dangerous object in time, we could prevent a catastrophe of dinosaur-killing proportions. Still, the cosmos is a wild place, and sometimes all we can do is watch, learn, and prepare as best we can.